This video will be on tangents and normals. It's going to be a fairly big video because it'll cover a fair bit of content. We'll start with looking at calculating the gradient at a point, then we'll go into calculating the equation of a tangent, then the equation of a normal, and then I will do some graphics calculator stuff right at the end on this too. First of all, calculating the gradient at a point. To calculate the gradient at a specific point, then we need to substitute the value of x into the derivative expression, because remember our derivative equation is our equation for also finding the gradient. So nice and easy, first example, find the gradient of the graph of f of x equals 5x cubed at the point where x equals 2. And then we're going to confirm this with our graphics calculator. So we'll do a graphics calculator straight away with this one, then all the rest will be at the end. First thing when we're doing this, we need to find our derivative. Our original equation is 5x cubed, which means our derivative equation will be 15x squared. Now to find the gradient when x equals 2, we sub x equals 2 into our derivative, which will be 15 times 2 squared, which equals 60. I'm now going to go over to the graphics calculator and show you how you can do this really quickly in there. So to do this in your GDC, you just need to go to a calculator page. And in your menu, you have an option number 4, calculus, and number 1, numerical derivative at a point, which is what we're finding, a derivative at a particular point. Our variable that you're working with is x. Our value is the value is the x value you are wanting to find the gradient at, which in this case is 2. And we just want the first derivative. Click OK. This will come up on your calculator screen, and from here you just type in your original function. You don't type in the derivative, you type in the original function, which in our case was 5x cubed. Press enter, and you will see there that it tells us our gradient of the graph 5x cubed at the point when x equals 2 is 60, which is exactly what we calculated by hand. Example 2. Find the values of x for which the tangent to the graph of y equals x cubed plus 6x squared plus 2 has the gradient of 15. Same situation though, we know the gradient, we have an original equation, which means first step is to find our derivative. We start with y equals x cubed plus 6x squared plus 2. Our derivative, y dash, would be 3x squared plus 12x. Then from here we know the gradient is 15. So we can just sub 15 into this for the gradient, which will give us 15 equals 3x squared plus 12x. You should then notice we can rearrange this to a quadratic, and then we can solve this. First step I would do would be to divide everything by 3, and then I can factorise. X plus 5 and x minus 1, which means our x values can be x equals negative 5 or x equals 1. Then you notice in the question as well, I wrote find the values, which tends to suggest there will be more than one solution. Next part, finding the equation of a tangent. The equation of the tangent to the curve of y equals f of x at the point where x equals a is given by, we've got our equation of the line here, y minus y1 equals m multiplied by x minus x1. Our m is the gradient at a specific point, which is what we just found before. x1 and y1 are our coordinates of the original point. So if we look at this picture here, we're finding the equation of that blue line there, so the tangent to that curve at that point A. And we want to find the equation of that line. First example, find the equation of the tangent to the curve y equals x squared plus 4x to the power of negative 1 minus 5 at the point where x equals 2. I always have a process with this and an order that I do things in. First thing I do is find the coordinates of the point. So we know that x equals 2, which means I'm going to sub that into the original equation. So we'll have y equals 2 squared plus 4 multiplied by 2 to the power of negative 1 minus 5. Simplify this, we'll get 4 plus 2 minus 5, which equals 1. So our original point was 2, 1. and this will be our x1 and our y1. Second step, we want to find m, which is a gradient at the point where x equals 2. Next step, find the gradient, so y dash would equal 2x minus 4x to the power of negative 2. Then from here, we're going to sub in x equals 2 to the derivative, which will give us 2 times 2 minus 4 times 2 to the power of negative 2, which will be 4 minus 1, which equals 3. So our gradient at that specific point is 3. So m will equal 3. And then from there, we can sub all our values into the equation. So we have y minus y1, which is, if we look back to part 1, so y minus 1 equals our gradient 3 multiplied by x minus x1, which was 2. And then we can leave that as our answer. It doesn't tell us how to give our solution. Obviously from here, if we wish to expand and put in the form y equals mx plus c, we can do that, but it's not necessarily. Just look at a question and see how it wants its answer and then just give accordingly. But in this situation, the first answer we gave would be acceptable. Example 2, the tangent at a point on the curve y equals x squared plus 4 passes through 0, 0. Find the possible coordinates of the point. The question says to find the possible coordinates. It tends to suggest we're going to have more than one solution. Now another tangent goes through 0, 0, so we have a point there that we might be able to sub in at some point. And we wanted to find the tangent, so first of all we need our derivative. So our y dash would be 2x. But we know our equation to the tangent will look like y minus y1. Gradient is going to be represented by 2x. We don't actually know what that is yet. Then we'll have x minus x1. We know one of the points on this line is 0, 0, which means we can sub that in as our x1 and y1, which will give us that y equals 2x squared. So now we have an equation to help represent coordinates of the point. Now from here we need to remember that our tangent and our original curve are going to meet, and that's the possible coordinates that we're looking for, which means we can then make these two equations equal each other. So our original one, x squared plus 4, and our new equation 2x squared for the tangent, because we want to know when are these two equal. You'll see we'll end up with 4 equals x squared. So x must equal 2 or negative 2. Now we're seeing that we're going to have two possible coordinates, and then from here we can find out what those coordinates are by subbing these x values into either of these two equations. So divided y equals 2 squared plus 4, so sub into our original, we'll get 8, so one equation would be 2, 8, and then our second one we want to sub in negative 2, which will also give us 8, so the other possible coordinate would be negative 2, 8. Lastly, we're going to talk about finding the equation of the normal. Just remembering the normal to a curve at a given point is perpendicular to the tangent. Because it is perpendicular, it means the gradient will be the negative reciprocal of whatever the gradient is that we find at that point. The rest of the process is the same, it just changes very slightly when we get to finding the gradient. In this example, find the equation of the normal to the function that equals x squared minus 4x plus 3 at the point where x equals 4. First of all, we need to find the y-coordinate of the point when x equals 4 on the original function. So we want f of 4, which would equal 4 squared minus 4 times 4 plus 3, which is just 3. So our original coordinate is 4, 3. Next, we want to find our derivative. So f dash x would equal 2x minus 4. And now we're going to sub in our 4 into this part to find the gradient at that point, which would be 2 times 4 minus 4, which equals 4. Now from here, our gradient is going to be the negative reciprocal of this. So we have positive 4, which means the answer will be negative 1/4. So that's going to be the gradient of the normal. So the 4 here is the gradient of the tangent. Then we do the negative reciprocal to get the gradient of the normal. And then the final step is to put it all into the equation. We'll have y minus y1, which is 3, equals our gradient, negative 1/4, multiplied by x minus x1, which was 4. And once again, there we have our solution. Now the last thing, I've got 2 examples here that I am going to do on the calculator. So just make a note down of the equations and what we are doing for each. The first one, we want to find the equation of the tangent to the curve, y equals 4 ln x at x equals 1. And in the second example, we find the x coordinate of the point on the graph of x e to the power x with a gradient of 2. For these 2 examples, we are going to be solving them in the graph function of our calculator. Now the first one, find the equation of the tangent to the curve of y equals 4 ln x. First thing we need to do is graph our 4 ln x. And we're wanting the equation of the tangent to the curve when x equals 1. So there's a few steps we have to do here. First step is we want to put a point on this graph at x equals 1. To do that, we go to Menu, Geometry, Points and Lines, and then Point On. Click on that, then just click on the graph anywhere. Don't press anything else, and then we're going to open bracket. And when we open bracket, it will let us edit the x coordinate. In this case, we want when x equals 1. So to type in 1, press enter, and it will plot that on the graph. Now to find the equation of the tangent, we go to Menu again, Geometry, Points and Lines, and you'll see number 8 is tangent. So click on that. Now once again, we just hover over the line, and you'll see when it meets the point that we've already put on there, it will come up looking like this. If we look at any point where else, it just highlights a graph, where once we look at that point on, we can click that, and then you'll see here, it tells us the equation of the tangent, y equals 4x minus 4. Example 2, we just want a new graph. And we want to find the x coordinate of the point on the graph of x e to the power of x with a gradient of 2. So with this, we actually want to graph the derivative function. Now we don't need to work out the derivative to graph it. We can go to this button here next to the 9. And in here you'll see the derivative, so the d over d. If you click that, and our variable is x, and then in here put our function, so it's x times e to the power of x. So this is going to graph the derivative function of this, which looks like that. Now we want the point on the graph where the gradient is 2. So now by graphing this, we're graphing the x with the y, and the y in this case is the gradient. So here then we can just press tab, and we want the gradient of 2, so we can just graph the line of x equals 2, and then we can find the intersection of those 2 points. So in Menu, Analyze Intersection, highlight the intersection, and we see there the x coordinate on the graph with a gradient of 2 is 0.375. And so you'll see from the calculator there, our answer to the example 1 was y equals 4x minus 4. And example 2, the x equaled 0.375. And that is equations of tangents and normals.